But how do these mechanics evolve? Mike mentioned the importance of observing processes and documenting opportunities for improvement. When we take those field observations and apply decades of engineering refinement, we get the kind of technological evolution our next guest represents. We're moving now from the field to the facility, and for nearly 30 years, Rob Eden and the team at Organics have been refining how we handle one of the most persistent challenges in wastewater treatment, ammonia. They've moved beyond just removing it to destroy it, to a new era of turquoise ammonia, recovering a vital resource using renewable energy. Let's hear Rob's interview with Piers Clark on how Organics turned pollution control problem into a scalable recovery solution.
Rob, brilliant to connect with you. Now, we're going to jump straight in because I know that there's been a huge amount of interest in nutrient recovery and in particular around ammonia. So tell me, what is it that Organics Limited is doing on ammonia? And let's be clear here, this is about ammonia recovery, not ammonia removal.
Yes. Well, we have been removing ammonia from wastewater since 1997, when we built our first plant in Hong Kong. That was rated at 1,800 tons a day of wastewater. Since then, we've done 17 different plants in Hong Kong, and we've evolved. The technology has evolved, and the methods have evolved to the point where we are today, which we'll come into in a minute, I suppose.
Yeah, I think it's incredible that you've been doing this for almost 30 years. I mean, that's staggering. But that was the work you did in Hong Kong was initially on ammonia removal rather than recovery. Is that right?
Well, in actual fact, we recover the ammonia and we pass it into a thermal destructor and destroy it. So we recover it and destroy it on site. And the reason for that is there's no market for ammonia in Hong Kong, and really the waste management companies are not interested in going into the ammonia business. So they just want to get it out of the water and get rid of it.
Yeah, and of course that was the 1990s. Now we're in the 2020s, where green ammonia, as it were, or blue ammonia, I think some people call it, environmental ammonia, is much more attractive. So you've moved to developing a system that can now do ammonia recovery at scale at any wastewater treatment works around the world. Is that right?
Yes. We call it turquoise ammonia because it's not green ammonia. It's actually got two benefits. It's ammonia from wastewater, so it's pollution controlled, and it's using renewable energy, waste heat or waste biogas or whatever. So we call it turquoise.
Great. Now, for the technical people listening to this, and obviously keep it relatively high level, in 90 seconds, tell me, how does the process work?
Well, the big contribution that we've made is to use waste heat to free up the ammonia in the wastewater. So you start with the ammonium ion, which is NH4, and you convert it to NH3. As NH3, it's a gas, and you can blow it out of the wastewater. Historically, people have used pH adjustment to break that bond and release the gas. Whereas what we've developed is a method of using waste heat to break that bond and make the gas available for removal. So one of the great, wonderful new innovations that we've come up with recently is that instead of using waste heat to run the plant, we're recycling heat. So that means we're taking the heat that's used at the outset and keeping it in the plant. So that means that we don't need to use waste heat or any heat at all. We can run the process with electricity just to keep the heat moving. So that's That is a scalable solution we can do from relatively small to very big, and we're quite hopeful that that's going to be an exciting breakthrough.
Piers, Rob, thank you. What Rob just described, the journey from a 1997 plant in Hong Kong to a modern, scalable resource recovery system, is exactly the kind of success story our industry needs more of. It proves that technological breakthroughs can transition from an exciting breakthrough into a global standard. However, as you'll know, that transition is not a straight line. There are thousands of brilliant ideas currently sitting in university laboratories that haven't made the jump to the commercial sector.